Yeah.
Okay, today's class, we will mention you results when we get in there, but at the beginning, let's do a review of a midterm exam. Okay, lab midterm exam. Okay, so midterm exam based on the syllabi. It is 50 points, and I usually add a little bit of extra points, so the total will be 54 points. So the total is 54 points, and if you get a total of 54, that's great. If you miss some, there are 4 points, which is the buffering. Okay, so I make it like that. Will be cover the lab from the beginning until last lab. So we will talk about that, so we're going to do the review. Okay, lab 1. What we did is microscope use. Microscope use. Okay, in this section, you should be know very clearly several things. Okay, how to calculate magnification. Okay, the total magnification calculated by the magnification of objective lens multiplied by magnification of ocular lens. By the way, the ocular lens is a lens close to your eye. So, give you an example. If the objective lens is 10x and your ocular lens is also 10x, therefore, the total magnification is 100x. Okay, usually this is the first question. I want everybody to do very well. The second question, what is parfocal? Do you still remember? We say stay focused once objective lens is focused. So which means you has been focused at 10x going to 100x with oil immersion. This is only a very minor adjustment. Okay? Number C, okay, what we talk about is oil immersion. What's the function of the oil immersion? To remove air gap, minimize the light refraction impact or effect. Impact. Okay, then we also talk about the resolution power, the calculation. If you still remember, is lambda divided by 2 and NA. What is RP? It's called the resolution power. The resolution power, remember, we talk about the value has to be smaller, which means the resolution power is strong, which means it's better resolution capability. Okay, that's the resolution power, the calculation. We also talk about the working distance. That working distance is decreased with increasing of objective magnification of lens or magnification of objective lens. Okay, so this is lab 1, what we talk about microscope use. And then you should have a picture which show you microscope the structure. You have a brief idea what it looks like. Okay. This is the first thing first. Okay, the second thing is lab 2. Lab 2, what we did is simple stain. When we do the simple stain, the principle behind that, you should be very clear, is the bacteria the outside is negatively charged, and all those dye are positively charged. That's why they can stick together. Okay, this is bacteria. Now, what is the basic, the simple stain, the procedure? That's what we call it a smear preparation. The smear preparation, including a very important procedure, we call it a heat fixing. Okay, what is the function of the heat fixing? Is to deactivate bacterial enzyme and then to let them to stick onto glass slides. Okay, that's heat fixing the function. Now, before the heat fixing, you should always remember there is an air dry before heat fixing, and we also gonna remember that smear has to be seen, which means it's not a very thick cloudy. The reason is that we are going to go into looking for is bacteria, cell, morphology, and arrangement. Okay, so these are the things that are important when we do a smear preparation. Now, what you find? We did the E. coli, we did the Bacillus subtilis. Both of them are large shape, and this is single large. This is also a large shape. It is single large. This is a little bit small. Okay, that's what you find for E. coli and the Bacillus subtilis. Okay, so this is lab 2, simple stain. Lab 3, we'll move on to is gram stain. And so far, you should be very clear about the procedure of the gram stain. And I said the procedure is very important. So the procedure of gram stain, you should be know very clearly. Number 1, crystal violet. Number 2 is gram iodine. Okay, it's like a mordant. Then number 3 is 95% alcohol. That's a decoloration. And the number 4 is safranin. That is counterstain. Okay, and we talk about that. We say the gram stain. This is A. The gram stain is to use young culture, usually less than 24 hours, because the principle is based on cell wall, okay, the peptidoglycan theory. And another one which we talk about is lipid theory. And you can go back to review it, okay? Now, what's the important thing for the gram-stem results? The results, you have to encode in is three important information. Number one is gram reaction. It is positive or negative. Number two is we call it a cell morphology. And the last one we call it is a cell arrangement. So we gave you some of the example what we did in the lab. If it's E. coli, it is gram-negative, lots, and single lots. If it's Staphylococcus aureus, you should be very clearly, it is gram-positive, coxal, and the grape shape, the arrangement. Is that right? Those are the two things we did in the lab. And you did the homework for serotia. What a serotia looks like is gram-negative and a little bit large lots. Is that right? For serotia. So that's all the things. Now, we also want to mention the last thing. There is a very possible two reasons will cause gram variable stain results. Which means they're going to all stain looks like gram-negative bacteria. What are the two major possible reasons? Number one is decoloration using 95% alcohol too long. Okay, number two reason is the culture is old. Older culture is more than 48 hours. Cell wall started to cracking down. Peptidoglycan, the structure start to breaking down. Okay, so this is the information for the gram stain. After doing the gram stain, what we did is endospore stain. So lab 4, what we did is endospore stain. And first of all, we mentioned about that there is a two bacteria has endospore, which is Clostridium and Bacillus. And we mentioned about that endospore, why it will be survive in a very harsh and environments, because in the center there is a calcium diproconic acids, DPA, calcium diproconic acids. And we also said it could be a small soluble DNA protein. And then we mentioned about that in the classroom, we're using Bacillus subtilis. As an example, we did the stain. Okay? What is the major difference between the endospore stem and the other stem what we did? Always remember there is a very special dye what we're using is malachite green. The malachite green we also accompanied with a special procedure is heat steaming. the heat steaming is 5 minutes, and there is a two possible way to do. One is using Bunsen burner. Another one is using hot water bus. The hot water bus is usually at the back, and the Bunsen burner, the heat is on the top. So this is a major difference compared to the other methods. Then what you find in the results? The results basically it looks like the indoor spore is right in the middle, looks like it's a malachite green color, or sometimes it is a big bubble. Is that right? And this indoor spore, the location, very possible, looks like it's a sub-terminal. And we talk about there could be terminal, sub-terminal, and it's going to be central. And the last thing we want to measure, this is this one. Last thing we want to measure is that in those spore structure, this is a protective function. This is not a reproductive function, which means the mother cell will not directly transfer to a daughter cell unless they both in a harsh environments. Okay, it's not a protective function. So this is from lab 1 to lab 4. We'll go over all these details. Is talk about the stand technology. I will take a picture of this. I have another one last year. Maybe it's better than this. So, but I'll take a picture of this. I'll put on the e-campus, and the students could be reading about it. You know, I'll put a screenshots there, and then you can still add a study guideline for it. Okay. So when we finish the lab 4, we are moving on to is aseptic technique, and following by the others, enumeration bacteria. So we want to talk about those things one by one. So let's remove these older material. Okay, just first of all, stay right here. We're going to lab 5. Lab 5, we talk about this aseptic technique. Now, first of all, you need to understand what is the definition of the aseptic technique, which means you're carrying a bacteria from slants or agar plates go to a media without carrying contaminants. So said very simple is without carrying contaminants into a fresh bacterial media. Okay, that's the definition. Now, then we did some practice. We did a practice which is in a broth. Okay, so in a broth, there is 3 markers to indicate a bacteria growing. What are the 3 markers? Pellicus on the top, precipitation at the bottom, or the turbidity, or we say the cloudy area. Okay, the 3 markers for bacterial growth. When we talk about this slants, what it looks like, it's a zigzag marker. This is for temporary storage of bacteria. Then that's going to be the key, streak plating. So what's the procedure for streak plating? The procedure for streak plating, if you remember, these agar plates will do very intensive first streak. Okay, then we flame the loop. This is number one. So we flaming loop. From the corner, we do a second streak, less intensive. The second one. So you have to flaming loop again. Do a third course right here. And sometimes you have to flaming loop again. Then do a last one. And then what you get, after incubation, you'll get those single colony. What this means, it's a single colony, which indicate a pure culture. So the function of the streak plating is you get a pure culture. Okay? So that's what we did for the lab 5. Lab 6, we'll just skip it because we do the unknown, and you already gave me the lab report. So we skip it. Lab 6 is unknown. We already talked about that. So lab 7 and lab 8 is we talk about is numeration. Numeration bacteria. Sorry. So we were using is number 1, spread plating. Number 2 is pore plating. Okay, you should be very clear about the procedure, how we did it. I'm not going to give you too much difficult quiz in the exam, but at least there's something you need to know. Okay, if I give you 3 tubes, what you going to get? I have a bacterial culture right here. I need to know the concentration. That is E. coli, let's say. Okay, every tube is 9.9 ml. 9.9 ml. 9.9 ml. So how we do it? We are adding 0.1 ml go to the first one, then we mix very well. Then we adding 0.1 ml go to the second one, we mix very well. Then we adding 0.1 ml go to the last one, we mix very well. Okay? So what is the dilution of the tube? 10 to the 2, 10 to the 4, and 10 to the 6. What is the dilution factor of the agar plates? 10 times more than the tube dilution. So it will be 10 to the 3, 10 to the 5, and 10 to the 7. What is the acceptable zone of the bacterial population, the colony number? What will be the acceptable zone is 30 to 300. What's the terminology of these things? So colony, that's called a colony forming unit. What's that? CFU. So let's do a calculation. If I have about 50 here, what's the final population there? At 10 to the 5th. That's very simple, is that right? 50 multiplied 10 to the 5. That is CFU per ml. And usually we change them to the log, so you can do the calculation. It's about 6.7 log 10 CFU per ml. You can use a calculator during the exams to do it. Okay. So this is something we already talked. Now we're gonna move on to your results. That will be part of the exam questions. We'll ask you to fill the table. So we want to talk about that. Okay, this will be a results table. So we talk about this lab 9 is bacterial media. Okay, let's look at the results table. What we have? E. coli. Is that right? Staphylococcus aureus. What we have? Citrobacter. Last one. What's that? MM. Okay, we just say MM. What's the media we have? Neutron agar. Makanki agar. What else you have? Blood agar. And mannitol salt agar. Okay, let's look at the results. First of all, everybody look at you. Neutron agar. Is that all grow? Is this correct? Is that all grow? You look at yourself, don't look at the results. I wrote, maybe I'm wrong. Is that all grow? Is that looks horrible? It's all in the cord, is that right? That's okay if it looks like this. Support media because everything is grow, so simple. How about Makanki agar? Which bacteria is growing? How about Makanki agar? Does E. coli grow? Grow, is that right? Staphylococcus aureus grow? No. Citrobacter grow? Yes. MM grow? Yes. Can you see the difference between E. coli and the others? Who has a good place? Which is in the coach? Who has a good place? Yes, take a look. Oh, no. So it seems like all those three looks like lactose fermentation positive if you look at it. It's a pink colony. So Staphylococcus aureus is not grow. Is that right? Absolutely, because it's gram-positive bacteria. And the MMCF and the EC, both of those three are gram-negative bacteria, so they all grow. It should be, looks like they're all pink. Is that correct? Yeah, looks like they're all pink. So why they're pink? This information is important. Why it is pink? Because lactose fermentation positive, is that right? So you should be recording LAC plus, lactose fermentation positive. Okay, let's look at the blood agar. Can you look at the blood agar? You will see, they all grow. Of course they all grow, because they are not fastidious bacteria. Which one you see transparent zone? Staphylococcus aureus, is that right? So this is the beta hemolytic. The others is actually gamma hemolytic. You don't have to write. If it's gamma hemolytic, it doesn't matter. Staphylococcus aureus is transparent zone. You can see very clear. This one, this guy didn't do very well, but looks okay. Transparent zone right here. Look at your own plates. There is a transparent zone for Staphylococcus aureus. Others is not, should be not. So gamma hemolytic others. Gamma hemolytic, you don't have to write. It doesn't matter. Okay, last one, mannitol salt agar, which one is grow? Mannitol salt agar, which one is grow? Can I see yours? I think you did good. Mannitol salt agar. Which one is grow? It should be only Staphylococcus aureus is grow. The others are nothing. If you have something grow, which means you get some contamination, okay, should be negative, positive, negative, negative. Did citric bacteria and MM grow? No. And Staphylococcus aureus, you could see it is yellow colony, is that right? Why? Mannitol fermentation positive. Okay, this will be the table you have to fill in the exam. Can you do it? Each corner, each one will be 1 point. Okay, is that easy? We're gonna grade it. If you miss something, we're gonna take the points off. It's so easy. Is that right? Let's give you a concept. 4 different bacteria, 4 different type of the media as a support, differentiate, selective. What's the results? And it's very clear in there. Now some of you didn't do very well because it's like messed it up. It didn't let it dry out. Then you just like flip it over. That's the reason. But some of you did really good. Okay. That is all our midterm exam review. Okay, now the question will be asked you, what is the best review material to do the exam? Can you tell me? Is your lab notebook? Is that right? Because you're recording all the results, and you go back to look at your lab notebook, you should see the detail what we did in the last 9 labs. So don't forget, is your lab notebook is the best way to do the review. Never forget about that. And I don't check your lab notebook, but this is the time to see whether you did a good job of lab notebook. Most of the time, people have a good recording. They're doing really good in the exam. Okay, so that's something to keep in mind. Okay.